Hi friends, this is Syed Reshma Sharif. In this video lecture, today I am going to discuss about a digital signal processing. Okay, first of all, what is a signal? Signal is nothing but a something that which conveys information. Okay, something that which conveys information is called as a signals. Signals are synthesized for communication between humans or and machines. Okay, it may be in between humans and machine as well as for in between humans. Okay, signals are represented mathematically as a function of one or two variables. Okay, here the signals are again classified into two types. First one is analog signal and second one is digital signal. Most of the signals are analog in nature. Okay, most of the signals are analog in nature, which means that the signals will be a continuous with respect to its time. Here this is an analog signal, whereas this one is a digital signal. Okay, this one is analog signal and this one is a digital signal. To convert a signal from analog to digital, to convert the signal from analog to digital, we can use a sampling quantization. Okay, to convert the signal from analog to digital, we can use a sampling quantization. Sampling quantization. What we will get here, we convert this signal into digital form. Okay, first to convert analog signal into digital form, the signal is sampled at discrete intervals of time. Okay, this is a discrete intervals of time. For converting analog signal to digital signal by using sampling quantization, here we are converting both signals. Once the discrete signal is obtained, the signal is converted into digital. To convert from discrete signal to digital signal, each sample is converted into a binary code and the sequence of binary code is known as digital signal. Okay, here each one having is converted into its binary code. Okay, so this conversion of binary code and the sequence of binary code is known as a digital signal. Now let us understand what is signal processing. Now let us understand what is signal processing. Signal processing is performed to analyze, modify and synthesize the signal. Here this process is performed to analyze, modify as well as synthesize the signal. So to analyze a signal, modify a signal and to synthesize a signal, we will go with a signal processing. Okay. For analyzation, modification and synthesization, we need to go for a signal processing. It is classified into, first one is analog signal processing, another one is digital signal processing. In analog signal processing, the signal is processed using an electrical network. In analog signal, the signal is processed using an electrical networks. Okay. Which is consisting of active and passive elements. Examples for active elements is op amp. For passive elements we can take capacitor, resistor, as well as inductor. Okay, so as an example, so using an electrical network, the analog signal will be processed in analog signal processing. Okay, so by using these electrical networks, analog signals will be processed in analog signal processing. In digital signal processing, an analog signal is converted into digital signal, then that digital signal is processed. After processing the signal, the digital signal is converted back to analog from analog form. Now let us understand the block diagram of a digital signal processing. In this block diagram, we can identify the different blocks like pre-filter pre-filter to digital, analog to digital converter, digital signal processing unit, here D to A converter, digital to analog converter, and here post filter here. Okay, first of all, let us begin with pre-filter. Pre-filter is a low pass filter. This is a low pass filter which allows frequency up to a certain threshold values. Okay, up to a threshold values. It alternates all the frequencies above the threshold values. These attenuated frequencies are unwanted frequencies that make it difficult to sample an analog signal. It is very difficult to sample an analog signal because here we are attenuating all the frequency above the threshold level now. So it is very difficult here. Next stage is analog. It takes the analog signals and produce a stream of binary data. Stream of binary data. Next one is a digital signal processor. In this digital signal processor, it is the heart of the system. All the signal processing is done in this unit only. Okay, this is the main heart of the system. All the signal processing is done in this unit only. Nowadays, CMOS, ULSI chips are used to make digital signal processor. These processor unit have high speed, high data throughputs and dedicated instruction sets. Okay, here it have high speed, high data throughputs and dedicated instruction sets in this digital signal processor, which are helpful in processing the signal. Which are helpful for processing a signal. Okay, next block is a digital to analog converter. It performs an operation opposite to analog to digital converter. Here we are already converting analog to digital. Again here it converts to digital to analog form. Okay, next that is post filter. It is also a low pass filter which smoothens the waves from the by removing the high frequency to obtain the desired signal, which will be an analog form. Here in pre-filter we are increasing the frequencies up to a threshold level. Here again it smoothens those frequencies in post filters, that which will be obtained in an analog form. Okay, this is the output, the analog output signal what we get from the output. This is y of t. These are all the advantages of digital signal processing or applications of digital signal processing. Okay, for example, for speech recognition, Speech synthesis, noise filtering, coding, compression of signals, etc. It can be used for image and video processing. For example, enhancing, coding, computation, animation, etc. It can be used for military spaces. Okay, for images and videos, for enhancing, coding, computerization, animation, etc. we are using. For military applications, on space applications, this can be used. For example, radar processing, missile guidance, etc. It can be used for biomedical and healthcare. For example, ECG analysis, extra analysis, scanning, etc. It can be used for consumer electronics. For example, consumer electronics are nothing but digital television, digital camera, mobiles, phones, interactive entertainment, etc. Compared to analog signal processing, digital signal processing can be performed complicated signal processing operations. Here are the advantages. These are flexible in operation, accurate result, stable system, data storage, low cost. Here, analog signal processing is not flexible. In signal processing and system design, it is complex. If you have a complex system, okay, then the system will be expensive. For some of the important advantages in digital signal processing are flexible in operation, which means digital signal processing can be made to give desired accuracy for result. Okay, it is made to give the desired accuracy of required degree by choosing the appropriate data. It is a stable system. Since digital signal processing operations are based on addition, multiplication, for so far the system will be extremely stable. The storage of the digital data is also less expensive and low cost. In this system, it is low cost due to the VLSI technology here we are using. VLSI technology here we are using, so this system is of low cost, which reduces the cost of memory, logic gates, microprocessor, etc. VLSI no. Here VLSI only, this technology will reduce cost of memories, logical gates and microprocessor, etc. There are nothing more disadvantage for this digital signal processing. It is having only a limited, nothing more disadvantages also. If you have a limited speed of operations, which is limited by digital signal processing. Okay, hardware especially at high frequencies of this is only one of the major disadvantage in digital signal processing. That is about the introduction of digital signal processing. I hope you will understand the topic. If you have any doubts regarding this, please comment me on my comment section. Please like, share and subscribe to my channel. Thank you. Thank you for your watching.